So this video is on the second part of Learning Unit 4, which is on the carbohydrate reaction. So in this subtopic, the learning objective is at the end of this lecture, students should be able to explain enzymatic and non-enzymatic Browning reaction and then list the effects of Maillard reaction and then explain steps that involve in Maillard reaction and also describe factors that can minimize the formation of acrylamide in food and explain how to inhibit enzymatic browning and also define crystallization of sugar and also explain steps that involve in starch hydrolysis. Okay, the first one, I'm going to talk about important types of browning. So in food, there are two types of browning. The first one is the enzymatic browning, and the second one is the non-enzymatic browning. So the first one, which is the enzymatic browning, it involves an enzyme which is polyphenol oxidase. So this browning usually involve fresh cut vegetables, for example, apples, potatoes. It is non-toxic and also no flavor. So when the tissue is cut or peeled, it rapidly darkens on exposure to air as a result of conversion of phenolic compound to brown melanoidins. So this is what happened. In fruits, for example, they have lots of this antioxidant compound, which is phenolic compounds. So phenolics compound, when it is exposed to an enzyme called polyphenol oxidase, it will turn into a brown pigment plus some flavor. Okay, the next type of browning is non-enzymatic. So non-enzymatic browning usually do not involve any enzyme. So the first type of non-enzymatic browning is caramelization, where it involves sugars at very high temperature. So when these sugars are subjected to high temperature, they will give some brown pigment plus flavor. The second non-enzymatic reaction is also called Maillard reactions, where this involves the reaction of reducing sugar and amine, and at high temperature it will give a brown pigments also flavor. So in this video, I'm going to talk about caramelization first, and then we'll continue on the Maillard reaction in the next video. Okay, so what is caramelization? Caramelization is the browning of a sugar, so a process used extensively in cooking for the resulting nutty flavor and brown color. This we always found in caramel pudding, or if you go to Starbucks, you order a coffee with some added caramel. So this is what the product of the caramelization. So sucrose can be caramelized. So this picture shows a caramelization in sucrose, where all the brown color is a result of browning, as sucrose is normally colorless. Okay. And caramelization is produced commercially as a coloring material and also flavoring material. And normally, the carbohydrate that are used in the caramelization is sucrose, which is the most often, followed by D-fructose, D-glucose, invert sugars may also be used. And usually, this caramelization reaction is facilitated by a small amount of acid and certain salts. For example, if we have acid here, we can use food grade sulfuric, phosphoric, acetic, and citric acid, but we must use the food grade lah. Okay, then we can also use base such as ammonium, sodium, potassium, and calcium hydroxides. And we can also use salts like ammonium, sodium, and potassium carbonates. Okay, there are two types of or two classes of caramel. The first one is the class 1, which is a plain caramel or caustic caramel. So this class 1 caramel can be prepared by heating a carbohydrate without a source of either ammonium or sulfide ion. So you do not introduce any ammonium or sulfide ion. So it will give you a plain caramel. Okay, the next class of caramel is the caustic sulfide caramel, where you prepare by heating a carbohydrate in the presence of sulfide ion, but in the absence of ammonium ion. So you have sulfide ion present, but there is no ammonium ion present. So this caramel used to add color to beers and other alcoholic beverages because it is a reddish brown color, and it has a solution pH of 3 to 4. Okay, class 3 caramel is what we call as ammonium caramel. So this class 3 caramel, it can be prepared by heating a carbohydrate in the presence of ammonium ions but in the absence of sulfide ion. So previously we have class 1, class 2. So class 1 is without sulfide and ammonium. So class 2 is with sulfide but without ammonium. Okay, class 3 is ammonium caramel. So it is in the presence of ammonium with ammonium but without sulfide. Okay, so this caramel is used in bakery products such as syrups and pudding, and it has a solution pH of 4.2 to 4.8. Okay, because ammonium is slightly alkaline compared to the sulfide. Okay, so when you have ammonium caramel, of course, its pH is slightly higher than those of sulfide caramel. Okay, now we have another class of caramel, which is class 4 caramel. So it is sulfide ammonium caramel. So it can be prepared by heating a carbohydrate in the presence of both ammonium ions and sulfide ions. So you have here class 4 has with ammonium and sulfide. Okay, this caramel used in cola, soft drink, acidic beverages, candies, pet food, and also has a solution of pH of 2 to 4.5. This pH is depend on how many percent of ammonium and how many percent of sulfate ion used in the preparation of the caramel. Okay, these are some important compounds that can be formed during caramelization. So the first one is furan. Yeah? Furan usually the structure of furan is like this, where you have a 5-membered ring, and at the top here, it is instead of carbon, it is replaced with oxygen. So it has a nutty aroma. For example, the hydroxy methyl furfural (HMF) and hydroxy acetyl furan (HAF). The second compound that can form after caramelization is diacetyl. So it mainly responsible for a buttery or butterscotch flavor. So if you are having a butterscotch flavored bread, so you can find diacetyl compound inside. So this is the structure of diacetyl, which is the dione, diketone. So 2,3 butanedione. So another compound that can form after caramelization is maltol. So maltol has a toasty flavor and used as flavor enhancer in bread and cakes. Normally, if we eat bread or cakes, we like the toasted flavor. So this flavor is contributed by maltol. Okay, and then we also can form esters and lactones from caramelization. So these esters and lactone, they can contribute to sweet rum like flavor. Okay, so that's the end of this video on caramelization. So next video we will talk about Maillard reaction in food.